Can a brilliant idea turn a car into champion? Or destroy a whole season? What if the key is in a single technical detail so extreme that it even touches the illegal? The birth of the Ferrari SF-25 front suspension was not simply the result of a technical need. It was a statement. A voluntary and strategic break with decades of mechanical inheritance. From Maranello, it was understood that continuing on the same path was not enough. After losing the title of builders in 2024 for only 14 points against McLaren, despite multiple improvements, Ferrari needed more than incremental solutions, required a complete reinvention. And that's where this story begins. The arrival of Loic Serra to the Scuderia was the catalyst for this transformation. It was not just a signing. It was the recruitment of a new philosophy. Serra came from Mercedes, a team that for years dominated the hybrid era thanks to its technical precision and its methodical approach. But in Ferrari he found creative freedom. The first thing he did was not look at the wind tunnel. It was to review the conceptual limitations of his previous designs. From his perspective, Ferrari had been working on an aerodynamic basis contaminated by conservative structural decisions, and the time had come to demolish the foundations. Among those ankylosed structures, the pushrod front suspension stood out. Although reliable and known, it was a system that conditioned the design of the direction arms, the height of the nose, and the placement of the mechanical elements in the upper part of the chassis. In the era of the soil effect, where air management below the car makes the difference between winning and disappearing, Ferrari could no longer afford that technical ballast. The pushrod system created aerodynamic interference with air entrance to side pods and the flat background. And what is worse, the possibilities of future evolution limited severely. It was a bottleneck. The decision to increase the wheelbase was the perfect complement to this revolution. When moving the cabin backwards, Ferrari managed to release space in the front of the car, facilitating the integration of the new suspension system and allowing the side pods to begin further back. This architecture not only favors aerodynamic flow towards the flat bottom, but also creates a more stable platform to exploit the soil effect. In theory, everything fit. In the world of Formula One, the difference between a theoretical advantage and a real gain is measured in millimeters and milliseconds. The pull rod suspension on the front axle of the Ferrari SF-25 represents a technical concept that, in paper, promised to raise the team to a new competitive plane. Its implementation was backed by CFD simulations, positive results in the wind tunnel and aerodynamic projections that indicated a clear gain in terms of efficiency and load generated. But as always, the theory does not drive the car on Sundays. The most obvious advantage of the pull rod suspension is its ability to release space at the top of the chassis. Unlike pushrod, which directs the loads from the wheel up, the pull rod makes the reverse path, pushes down from a lower point than the chassis. This rearrangement allows a reduction in the volume of the upper components, making possible a more sharp, clean, and less obstructive aerodynamically. In practice, this translates into a lower turbulence in front of the pontoons and a purer input of the air flow towards the critical elements of the soil. This is not just technical aesthetics. It is a crucial step to maximize the performance of the soil effect, which in the current regulations of Formula One is the undisputed king of yield. A clean flow allows the diffuser and the flat background to work in optimal conditions, generating more load without increasing progress resistance. The SF-25, with its reconfigured architecture, seemed to be the ideal vehicle to capitalize on this principle. The theory argued that Ferrari could run with a lower march height, maximizing the suction of the car to the asphalt, without paying the usual price in terms of stiffness or rebounds. If there is a point where a revolutionary design like the SF-25 faces its true judgment, it is on the track. The asphalt does not forgive. What in theory seems impeccable can collapse when the unpredictable variables of the race come into play. And in the case of Ferrari, that test has been brutal. The car that promised to be an aerodynamic masterpiece has become a logistic headache and a constant regulatory risk. The key to the problem is underneath, where almost nobody looks at, on the floor of the car. Or more specifically, in the weary plant, also known as skid block. This component, although it seems insignificant, is one of the strictest guardians of the legality in Formula One. Is made of a synthetic material called jabrock, and its function is to ensure that cars do not roll too low, something that the FIA considers dangerous and contrary to the spirit of the regulation. The measure is clear. At the end of the race, the space must be at least 9 millimeters thick. If we wear beyond that limit, the sanction is immediate and without appeal, disqualification. And that is exactly what happened to Ferrari. The front pull rod suspension, together with the new aerodynamic configuration of the car, forces the SF-25 to run extremely low so that everything works as designed. But that same need puts it at a constant risk of bouncing more than the account, touching the ground and wearing the skid block to sanctionable levels. Ferrari has tried to correct this by increasing the height of the car, but that destroys the foundation of its design, run under to exploit the soil effect. It's like building a house on a pool. If you fill it, it floods. If you empty it, it sinks. And there is another hidden problem. The dynamic behavior of the car changes drastically depending on the fuel load. In the first laps of a race with the full tank, the SF-25 tends to compress the suspension more, which aggravates the risk of premature wear. Then, when the car is lightened, aerodynamic balance changes again, affecting traction and curve passage. This volatile pattern makes the car extremely difficult to calibrate. Each decision made in classification can become a disaster in the race. The margin of error has become so narrow that the technical team has had to redesign whole simulation protocols, review each setup change with surgical precision, and still they cannot guarantee that the car complies with the regulation after a demanding career. This permanent uncertainty has made Ferrari live every Sunday with fear. Fear of being fast and being punished for it. Fear of trying to get the maximum performance and end up disqualified by 1 more millimeter. The most worrying thing is that this is not a problem that is fixed with a patch. It is not enough to adjust a piece or modify the adjustment to solve it. It is a structural defect in the way the car was thought. The SF-25 was born with an internal conflict. To perform at the maximum, it needs conditions that dangerously bring it closer to the edge of legality. And when he is forced to respect those rules, he becomes a common car without any differential advantage. In that dilemma, Ferrari is caught. He has designed a jewel that can only shine if he risks breaking the rules. But in a sport where legality is sacred, that is a bet that only leads to a war against oneself. An operational window is, in essence, the range of conditions in which a F1 car works with optimal efficiency. It may include factors such as tire temperature, fuel loading, asphalt height, compound type, air pressure, humidity, track rubber level, aggressiveness of the setup and driving style. In an ideal car, this window is wide, generous. The tolerate car tolerate variables, adapts, allows its pilots to push without fear. But in the SF-25, this window has narrowed until it becomes almost non-existent. Any small deviation of ideal conditions makes it an unpredictable, unstable, or directly slow car. This erratic behavior is further aggravated by the extreme design of the chassis. Having opted for a configuration designed to operate as low as possible to the ground, Ferrari has sacrificed tolerance in his suspension. There is no margin for flexibility. The pull rod system, although it allows aerodynamic advantages, does not forgive mistakes. And this makes the car not only difficult to configure for engineers, but also stressful for pilots. It requires them to pilot the limit, but without passing a millimeter of that limit. Even tire management has become a challenge. The SF-25 is able to generate an extraordinary aerodynamic load, but only if the tires are in their optimal temperature range. And that does not happen naturally. In cold sessions, the compounds do not reach the right temperature on time, and the car loses grip. In races with high temperatures, on the contrary, the SF-25 tends to overheat the front train, compromising the useful life of the tires and forcing anticipated stops. It is a loop of limitations that make a flexible strategy impossible. And when a car needs to roll so low that each clue bounce can disqualify it, we are not alone in a technical genius. We are witnessing a design that has bet all its success to a fragile letter. Ferrari has sought to extract performance without violating the rules, but also without leaving margin to imperfection. And in Formula One, that margin is essential. The potholes of an urban circuit, the change in atmospheric pressure, an unexpected yellow flag that cools the tires, each of those factors can push the SF-25 out of the safe land. And then all the engineering behind the design becomes a threat to the team itself. The real risk is that, in this search for technical genius, Ferrari has created a precision monster that cannot survive in hostile nature that is a weekend of Formula One. Technical genius becomes madness if it cannot be reproduced reliably, and becomes illegality if it crosses, even without intention, a technical border. The conclusion of the SF-25 case cannot be locked in one sentence, because the car itself represents a living paradox within the modern Formula One. Ferrari has created a car that, in theory, embodies the best of technical innovation, the most advanced of soil effect aerodynamics, and a brave reinterpretation of concepts that the rest of the grille considered untouchable. But at the same time, it has given life to a design that defies the basic operational logic of this sport: consistency, adaptability, and regulatory compliance. In that tension the Scuderia lives today. And that leads us to the big final question. Is this car a precursor to the future of Formula One? Or is it a silent warning about the dangers of innovating without security network? Maybe both. The SF-25 will remain in history, not because of what it achieved so far, but for what it represents. A symbol of what can happen when the technical genius meets the raw reality of the highest level sport.